Now, counting sig figs, now we're going to talk about using those in a calculation because that's more realistic of what we would do. So there's two different rules depending on what kind of math operation you're doing. So if you're doing addition or subtraction, then when you get your answer, it should be rounded off so as to contain the same number of decimal places as the number with the least number of decimal places. So in other words, like we talked about yesterday, you cannot have an answer from an answer that's more precise than your measurement. So if you're adding or you're subtracting, you're looking at places behind the decimal. Right. So here would be an example. I'm adding these three numbers up. I put that in my calculator, and this is what I get. Obviously, that's showing a lot more precision than 4.1. So since I'm adding, I need to come back and I need to look at my numbers. This one has the fewest numbers behind the decimal, so that's what my answer has to have. That has one place behind the decimal, so my answer can only have one place behind the decimal. So that is where my 6 is, because there's a 7 behind it. It would be rounded up and it would become 48.7. Just round at your sig fig. And what I mean by that, like if I had 52.448, okay, let's say that that was my number. And once again, I only wanted one place behind the decimal. Just look at the 4. That is one place behind the decimal. And since there's a 4 behind it, you would leave it as 52.4. Sometimes people try to get farther down and they're like, oh, well, here's an 8. 8 rounds that up to 5. Well, now it's a 5. So don't just only go to where the sig fig that you're interested in. Don't go deeper into the number and start rounding. It's going to mess you up. All right, why don't you try these two? You can put them in your calculator, you can do them in your head, and then adjust for significant figures. So when you put the first one in your calculator, what did you get? You got 11, but in the calculator originally. That's what, yeah. So you got 11.295. But then, like you said, I could only have one place behind the decimal, right? So that is where my 2 is. So since there's a 9, it would become 11.3. That's the correct way. What about the next one? What did you get? 150. Do I need to make any changes to that? That one's good. All right. All right. So that one is if you're adding or subtracting. And now there's another set of rules if you're multiplying or dividing. That's what makes it kind of hard. Sets of rules. So, okay, so 7.44, and now what do you ask?
Like, let's say, like the lowest number goes down to 7.1.
Could have 2 places past the decimal, and you got that, then that's good. You don't do anything else. Yes, sir. All right, we do really more multiplication and division throughout the year, so we're going to use this rule more. So if you're multiplying or dividing, the answer should be rounded off to contain the same number of digits as found in the least accurate of the values. So now instead of looking at places past the decimal for multiplication and division, you're counting your sig figs. All right, so for instance, if I multiply those two numbers together, I get all of that in my calculator, but I have to come back and look. This is my least precise. It has 3 sig figs, so my answer can only have 3 sig figs. So that's where my 0 is. Since there's a 6 behind it, I would round it up to 8.1. So two different sets of rules. That's kind of one of the things that makes it a little bit harder. All right, why don't y'all try those next two? See what you get. All right, on my first one, what did I get when I put it in the calculator? That's what I got in my calculator. How many sig figs can my answer have? Only 2 because of that 14. So the 2 is my second, or is my second, yeah, is my sig fig, my second sig fig. Since it has a 7 behind it, I'm going to raise it up to 3. What else do I need to put there to be a placeholder? A 0 with no decimal. This number is in the magnitude of hundreds. I can't just leave it as 33 because then I've gone all the way down to the magnitude of tens. That's too big of a change. So, but if I put the 0 here without a decimal, it's not significant. You also could have put that in scientific notation, and then you could have also done that and you could get it to just 2 sig figs. So some of those are a little bit tricky. My next one, what did we get? 5, right? In your calculator. Do I need to make any adjustments? No, because both of them actually have 2 sig figs, right? 2 and 2. So that does 2. So I'm good to go. All right. So let's talk real quick about scientific notation, just reading it as far as sig figs go. I know y'all know how to write scientific notation. We'll refresh your memory next week, I think. All right, so if you're given a number that is already in scientific notation, the sig figs come just from the coefficient. That's what that part's called, coefficient. They do not come from the base that has the exponent on it. So if that's true, I look at 1.23 and that is 3 sig figs. Same thing here. That's already in scientific notation. Those 4 numbers. So I have 4 sig figs. If you have a number in standard form, so this is standard form, how we usually write our numbers. You got to count the sig figs. And then when you change it to scientific notation, it has to have the same number of sig figs. So in other words, this one has 5. So when I put it in scientific notation, it still has to have 5. So I'm going to go 1, 2, 3, 3.250 times, see, not 0. 25. Where am I at? I feel like I've lost a number. That was okay. 0.9 times 10 to the negative 3. Supposed to say that. I know it's hard to read. All right, and the last thing we're going to talk about are counting numbers or exact numbers. It's a rule I'm going to talk about. It's not really going to apply at this part this part of our unit this much, but as we do it again, I will talk about it again. So some numbers are considered can't talk all of a sudden. Exact numbers, which means that they are known with complete certainty. So those kind of numbers could be counting numbers. If I say there's, I don't know, 27 of us in here, that is a counting number. We know that with complete certainty. Even though we don't write it, it's really 27.0000 for a very long time. So those do not affect sig figs. Other things that do not affect sig figs are conversion factors. So for instance, if I use the conversion factor of there's 12 inches in 1 foot, those are exact numbers. We don't put this whole bunch of zeros behind them, but they're considered exact numbers. So they do not affect the sig figs in that problem. The other thing that doesn't affect them would be constants. So we'll do different times throughout the year where we'll have a formula and it'll have a constant on there that we'll pull off of a reference sheet. That does not affect the sig figs either. So the number of apparent significant figures in any exact number, all these examples I gave you, would be ignored as far as talking about our limiting factor that would affect our sig figs. Like I said, when we actually start using some of those numbers, I will bring that up again. If you look at the back of your flow chart, those are the rules as far as adding, subtracting, multiplying, or dividing. So if you want to add any notes to that, you can do that. You know, you might want to put where it's adding and subtracting. You might want to say you're looking at places behind the decimal. And then down here where you're multiplying or dividing, you might want to put the counting sig fig, something like that, if it helps you. Some of you may not need that. All right, so now y'all are going to have some time to work on your practice. I will come around and see if you need help. We will end with a lesson check. If you look at your practice to begin with, number 11 is incorrect on the key. If you flip over the key, because you're going to state the number of sig figs, they're just bolded on the key. It just has 2, but this one should be how many? 4, 6. So that is a key is wrong on that one. 5, 6. Yeah, this is our practice. Another one that I've seen people struggling with is number 5. And like they're putting it in their calculator, making it a lot harder than it is. Remember, if you have a number that's already in scientific notation, you're just interested in that part. You don't have to worry about that part. So that would be 2. Yes, ma'am. You'll have to go under the 30th yesterday, and you'll have to dig through that and find it. Like 4 things, we picked up 4 things yesterday. So you're probably gonna have to look around a little bit.